Welcome to A-Level Physics. We'll continue our topic Dynamic 3.3 Principle of Conservation of Linear Momentum. Right. It's still the same, hasn't changed. Total momentum of a system of interacting bodies remains constant, provided no external force acts on the interacting bodies. Right. These are all the formulas that we have obtained. Right. Definition of momentum, change in momentum, that's the force. Definition of Newton's second law, alternative form of Newton's second law, and then Newton's third law. But today's topic is conservation of momentum in 2 dimensions. Right? We can still use our vector triangle to find our resultant, or we can use component method. One vector resolve into component. Right? Either way, we can use that. Right? So these are some of the formulas that remember. This is a vector equation. Right? This is total momentum initially. This final momentum initially. Sorry, this is the total final momentum for two-body collision. The vector equation, you need to use the vector triangle to find the resultant vector, or use component method. If it's linear momentum, it's easy, one dimension. That's why we add and subtract. But now we have to draw a vector triangle, or use component method. Momentum is conserved, not velocity, remember that. Momentum is conserved. Right? So this is the two atoms colliding. This is before, this is after. So this is the initial momentum for particle 1. This is the initial momentum for particle 2. This is the final momentum for particle 1. This is the final momentum for particle 2. So we have to take the angle into consideration. The angle there is the angle. And there is the final momentum of 1. There's final momentum of 2. Same direction. And we have our initial momentum. Initial momentum. That's our initial momentum. Right? That's the resultant momentum if you like. Anyway, let's go into a specific example. A plug A, like a plug on a frictionless surface, collide with a stationary plug B, as a plug B, as shown in figure. After collision, the plug moves as shown. This is stationary. This is after collision. If A moves this way, B moves that way. Use the information in figure to find the mass of plug B. And to find the mass of this one. We don't know the speed, the velocity of the A, so we just call it U. Can draw it in terms of vector. That is the initial momentum, 0 point mass times velocity, initial momentum. And momentum for A is the mass times velocity. Mass times velocity, that's what we get. And this one is the same. We don't know the mass, so let it be m times 0.3, 0.3 m. Okay, that's the same picture. Right? Remember the initial momentum, sum of momentum initially equals sum of momentum finally. Or we can write the equation. B is stationary, so we don't bother about that. That's the initial momentum of A, initial momentum of B, sorry, final momentum of A, final momentum of B. Right? That's a vector equation. Okay, let's draw that. Right? That's the final momentum. According to this vector equation, that's the final momentum. 30 degrees to horizontal, 30 degrees or 30 degrees there. Final momentum of B, that's the B. 40 degrees to horizontal, 45 degrees to horizontal, 45 degrees to horizontal, 0.3 m. Remember, we are working with momentum, not speed or velocity. There's the opposite alternate angle there, 45 degrees. Then we can calculate this one, 180 minus 30 minus 45. So this is 105. So we can use sine rule. Sine rule is momentum over sine 30 equals to, right? This is known. So use that. 24 divided by sine 45. So cross multiply. Use calculator and calculate your m. Okay. And if we are required to calculate u, we can calculate u, no problem. And we have calculated m. We can use cosine rule. Calculate the u. That's one way of using vector triangle. Cannot work with velocity, as velocity is not the one that is conserved. Work with momentum, as momentum is conserved. Identify the resultant momentum. In this case, the vector will tell us this is the resultant. From the vector equation, that is the resultant. We can use we can resolve the vectors. Resolving both vectors should get resultant momentum. Non-vertical resultant momentum, we can use component method. This one doesn't have a vertical component. That one can have a vertical component and a horizontal component. Same with this one. Let's try that. Okay, that's the vector. Just draw the vector, good enough. Same vector. Well, resolving vertically, since you want to find m, we don't know u. So resolving vertically, right? That's represent that as a vector momentum. Then we solve this one vertically. It's 0.24 sine 30. Resolving this one vertically, 0.3 m sine 45. So these two must be equal. 24 sine 30 equals 0.3 m sine 45. From this we can calculate our m. Take 0.3 sine 45 downwards. Using calculator, calculate our mass. Right, we can resolve it. If we are required to find u, we can resolve this one into horizontal component, which is that one there, and then resolve this one into horizontal component. As we will do here, resolving horizontally, 0.6u is this one, equals to 0.24 cos 30, and the other one is 0.3 m cos 45. M is given, and we already calculated before. So put in the value, calculate out. From there, you can calculate our U. Okay, let's try another example. There are other examples. Use there's the momentum, this one. There's the momentum, final momentum for body 2, body 1. Doesn't matter which we start with. We can start with this one if we want to. Right? Doesn't matter which vector we start. We can add it anyway if we want. Either start with this one or start with this one. Or it can be this example. Right? There's the initial momentum. There's the initial momentum. Them up. And then there's the final momentum. Okay, let's try the example. A ball of mass 1 kilogram. This is A, 1 kilogram. Moving with velocity 4 meters per second, strikes at a glancing blow on a second ball B, that's ball B, which is at rest. After collision, ball A move off at this ball A, move off at right angle to its original direction with a velocity of 3 meters per second, as shown in figure. What's the magnitude of the momentum of B after collision? And find momentum of B after collision. In what direction was B moving after collision? On the direction of B after collision. Now we are given the mass of B is 5 kilogram. Given what is the speed after collision? The speed of this one after collision. If the impact time is 0.02 seconds, what is the magnitude of the average force acting on B during collision? So we are interested in force on B. So to find the force, we look at this is initial, this is the final. Okay, let's just redraw what we have given. Okay, we want to find the final momentum of B and its direction and the velocity. Okay, our initial momentum of A, 4 times 1, 4, then this one is 3, and draw in its vector form, 1 kilogram. This is 1 kilo, 1 times 3 is 3. That's what we are known. Then using our conservation of momentum, write our vector equation. AI, this is 0, so we don't have to worry about that. Then there is a final momentum. That one there. Here we don't know, we just represent it as BF. Then we write our equation, take that across there. BAI minus BF. So minus factor means plus minus that. So we draw our AI first. That's our AI, the direction. Then instead of plus AF, AF would be here plus AF. You want minus AF. Minus is minus 3 here. Right? Minus 3 here. Then that's our final BF. You want to find that magnitude and this angle. Okay, so it's just 3, 4, 5. Or using Pythagoras theorem, 4 square plus 3 square equals to 5. Square root that, 5. Then we find the angle, this angle, shown a diagram. That's your angle theta. So it's 3.4. It's 9 degrees. Then we want to find the velocity. That's your final momentum of B, mv. Right? M is 5. So that 5 is contained from here. Momentum of V is 5 divided by 5, 1 meter per second. Okay, if the impact time is 0.02 seconds, what was the magnitude of the forces exerted on B during the collision? Right? That's your previous picture. Right. Calculate the force. We use the force formula. Okay. We are concentrating on B. Initially is U equals 0. For B, U equals 0. Finally is 1. Mass is 5. Time is given 0.02 seconds. Put in your value there, calculate out. Okay, so that's the end of the topic. Thank you for your time.